Hello everyone, this is Vivin Arana and today we are going through GraphQL. Now in this particular video series, we're going to go over a comprehensive and quick look at GraphQL so you can get up and running with GraphQL. So to start off with, what is GraphQL? GraphQL is a query language for APIs and a runtime for executing those queries by using a type system you define for your data. Like unlike REST APIs, where clients have limited control over the data they receive and often require multiple requests to fetch related data, GraphQL allows clients to request exactly the data they need in the format they need it with a single request. Some of the history and evolution of GraphQL is like it was developed by Facebook in 2012 to address the challenges they faced with their mobile applications, where they needed more flexibility and efficiency in data fetching. It was later open source because it got so popular that it got open sourced by Facebook in 2015 and has since gained significant adoption by various companies like GitHub, Shopify, and others. Now, some of the key concepts include queries. Now, GraphQL queries are used to fetch data from a GraphQL API. They describe the shape of the data the client wants and follow a hierarchical structure similar to the shape of the data that will be written. Next is mutations. Mutations are used to modify data on the server. They are used for creating, updating, and deleting data. Next, the concept is the subscriptions. Subscriptions allow clients to subscribe to real time events or data updates from the server. This enables building real time features such as live notifications or chat applications. We also have a schema definition language, which is SDL. SDL is the syntax used to define the GraphQL schema. It defines the types available in the API and the relationships between them. We also have resolver functions. Resolver functions are functions responsible for fetching the data for a specific field in the schema. They are written by they're written by the server developer and determine how data is fetched from the underlying data sources. And we will be looking at all these concepts in detail in the coming videos or in later in this particular series. So some of the advantages of GraphQL over REST, like why would I go with GraphQL versus the well-known REST mechanism there is. Now, first thing is it reduces the overfetching. Now, clients can specify exactly what data they need, eliminating the problem of overfetching data. Next is batching request, where clients can send a single query to fetch data from multiple endpoints, reducing the number of HTTP requests. Next is its strongly typed schema. So GraphQL APIs are defined by a strongly typed schema, providing clear documentation and enabling powerful developer tools. We also have the evolutionary API development with GraphQL. You can evolve your API over time without breaking existing clients by adding new fields to types or deprecating old ones. So it helps quite a lot. Now, what we have learned here is we've kind of laid down the foundation a foundational understanding of what GraphQL is. We learned about its history and its key concepts, and also we set up the stage for deeper exploration into building and consuming GraphQL APIs in the subsequent videos. We'll go over that. If you have any questions until now, post them in the comments. And if you need more explanation on any particular topic, we'll probably go over them. But if not, just post them in the comments and I can create another video for that. Thank you again. The next that we have, or we're going to go over, is like setting up the GraphQL server. Now, first thing that you have to select is you have to choose a GraphQL server implementation. Now, when setting up GraphQL server, you have several options to choose from based on your project requirements and preferences. Some popular GraphQL server implementations include the Apollo server. Apollo server is a flexible, community-driven GraphQL server that works with any GraphQL schema language and integrates seamlessly with popular JavaScript frameworks like Express and HAPI. Happy. Express, the second server is the Express GraphQL. Now, Express GraphQL is a lightweight and easy to use GraphQL server implementation specifically designed to work with Express.js, a popular web application framework from Node.js. If you're not familiar with this, I don't think this is for you. Next one is the GraphQL Yoga. GraphQL Yoga is a fully featured GraphQL server built on top of Apollo server and Express.js. It provides additional features such as built-in support for GraphQL subscriptions, file uploads, and more. So now that we know what are different servers are available, let's look at how do we go about setting up a basic GraphQL server. Now, regardless of the server implementation you choose, setting up a GraphQL server typically involves these following steps. The first step is install dependencies. Now, install the necessary dependencies for your chosen server implementation, such as Apollo Server, Express, or GraphQL Yoga, along with any additional libraries or tools you need. Next is define a schema. Now, you have to define your GraphQL schema using the schema definition language, which is SDL. This includes specifying the types, queries, mutations, and subscriptions supported by your API. The third step is to create resolver functions. Now, write a resolver function to implement the logic for fetching data for each field in your schema. Resolver functions are responsible for returning the data requested by clients. Next, what you need to do is configure your server. Configure your GraphQL server by specifying the schema, resolvers, and any additional options or middleware you may need. This may involve setting up routing, error handling, logging, and other server configurations. Next step, start your server. Now start your GraphQL server and listen to the incoming request from the clients. Once the server is running, clients can send queries, mutations, and subscriptions to interact with your API. So let's go over defining a particular schema. How do we define a particular schema? The GraphQL schema defines the types and operations supported by your API, including the available fields, their types, and the relationships between them. The schema serves as a contract between the client and server, specifying how clients can interact with the API. An example of a simple GraphQL schema definition might look like this over here, where we have the type query, hello string, and type mutations. Now, in this particular schema, we have a query type with a single field hello that returns a string. As you see, hello colon string. We also have a mutation type with a single field update hello that takes a new message argument and returns a string. So if you look at both of them, one of them is kind of just like a variable if you're used to programming, and second one is more of like a function where you pass something and you pass a string to it and it will give back a string. Now, next thing that we want to look at is how do you create resolver functions? Now, resolver functions are responsible for fetching the data for each field in the schema. Resolver functions can be synchronous or asynchronous and typically return in JavaScript or another programming language supported by your server environment. For example, a resolver function for the hello query field might look something like this here. So check this out. Here we have the constant resolver where we have a query which has a hello function which returns back hello world, and the mutation which takes the update hello function that we defined before and passes the message and returns the message back. Now in this resolver function, we simply return the string hello world for the hello query field, as you see on the third line. Similarly, for the update hello mutation field, we extract the new message argument from the input parameters, and return it as a result of the mutation. So now following all these steps that we defined above, you can set up a basic GraphQL server and define a schema with resolver functions by a resolver function which help you to handle incoming queries, mutations, and subscriptions from clients. So if you have any questions on this or whatever we went through in this particular section, let me know, and we'll be looking at GraphQL queries in the next section. Now let's go over the GraphQL queries. Now, let's go over some of the query basics. In GraphQL, queries are used by clients to request data from a GraphQL server. And unlike traditional REST APIs, where each endpoint corresponds to a specific resource, GraphQL APIs have a single endpoint, and clients can specify exactly what data they need in their queries. Now, how does the query structure work? Now, GraphQL query consists of a series of fields that represent the data the client wants to retrieve. The structure of a query mirrors the structure of the data that will be returned, allowing clients to request nested and related data in a single request. For example, a simple GraphQL query might look something like this, where we have the query, user ID 123, name, email, post, title, body, and then the closing brackets. Now, in this query, the client is requesting the name and email fields for a user with ID 123, as well as the title and body fields for each post belonging to the user. So if you see how the query is written here, we have you specify which user. So for user ID 123, give me back the name and email and all the posts with their title and body for that particular user. Let's look at query variables next. Now, GraphQL supports query variables which allow clients to pass dynamic values into their queries. This is useful for scenarios where the client needs to filter or paginate data based on user input or other external factors. For example, a query with variables might look something like this, where query, I'm saying get user, and the user ID is the variable with where ID is, if it's there, if it's good, it's not, it has to be available is what we need. Is an ID is mandatory, and inside there where I have the user, I'm passing that user ID and it returns back name and email. Now, if you look at in this query, the dollar user ID is a variable that represents the ID of the user to retrieve. The client can provide the value for the variable when executing this particular. Let's look at field aliases. Now, field aliases allow clients to rename the fields returned in the response. This can be useful when querying for the same field with different arguments or when multiple fields have the same name but represent different data. For example, a query with field aliases might look something like this here. If you look at it, in this particular query, the name field is aliased as full name and the email field is aliased as email address for both the first user and the second user queries. If you look at it, that's on line number 3 and 4, we have full name email addresses. For the second user, just below it, we are specifying the aliases. Next, let's look at fragments. Now, fragments allow clients to define reusable pieces of query logic that can be included in multiple queries. This helps to avoid duplication and maintainability issues in large GraphQL schemas. For example, a fragment might look like this. Now, in this particular query, the user info on the first line syntax includes the fields defined in the user info fragment for the user query. If you say I'm saying fragment as name and email, now inside my query I can just say dot 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 user info and it will pass me the names and email. So this kind of helps you with reusability and bunch of different things. Now let's look at directives. Directives are used to conditionally include or exclude fields or fragments from a query based on certain conditions. This allows clients to control the shape and content of the response data dynamically. For example, here we have a query with directives, which looks like this. In this query, the @include directive is used to conditionally include the post field based on the value of the include post variable. So now, by understanding all these concepts that we went through and techniques, clients can actually construct powerful and efficient queries to retrieve the exact data they need from a GraphQL API. So I hope this helps just to get the basic understanding, and we'll look at more in the future sections. Next section that we're going to look at is GraphQL mutations. Now, let's go over some of the mutation basics. Now, in GraphQL, mutations are used to modify data on the server. They enable clients to perform operations such as creating, updating, or deleting resources. Now, mutations follow a similar structure to queries, but are used for making changes to the data rather than just retrieving it. So, until now, we just looked at how to retrieve data, but this mutations is all about updating on the backend. Now, mutation structure, how does it go? A GraphQL mutation consists of a mutation operation followed by the name of the mutation and any input parameters required by the mutation. Similar to queries, mutations can return data in the response to provide feedback to the client after the mutation is executed. For example, a simple GraphQL mutation looks something like this here. So start with mutation. You say create user. In this mutation, the create user mutation is used to create a new user with the specified username and email. So we pass the input as username and email in this JSON type format, and this mutation will return back me the ID, username, and email of the newly created user in the response. Now, ID, what happens is when you create this user on the server side, you'll probably assign it a particular ID and return this back. Let's look at input types. Now, mutations often require input parameters to specify the data to be modified or created. Input types are used to define the structures of these input parameters in GraphQL schema. Now, input types are similar to regular object types, but are specifically designed for input data. So, for example, an input type for creating a user might look something like this, where you have input, create user input, and we pass username and email. Now, in this input type, the username and email field represents the data required to create a new user. Let's look at mutation variables. Like queries, mutations in a GraphQL can also use variables to pass dynamic values into the mutation operation. This allows clients to parameterize mutations and make them reusable across different contexts. For example, a mutation with variables might look something like this, where you have mutation, create user, and you're creating the variable input, where you're getting the create user input, and inside create user input, you are having the input variable assigned to input, and it returns back ID, user, and email. So in this mutation, the input, the $input variable represents an object containing the data required to create a new user. The client can provide the value for this variable while executing the mutation. Next, look at error handling. Now, GraphQL provides mechanisms for handling errors that occur during mutation executions. Servers can return errors along with the response data to inform clients about any issues that occurred during the mutation operation. Now, for example, here is if a mutation fails due to a validation error or other constraints, the server might return an error response that looks like this, where we have a JSON object which has errors array which has message and path inside. Now, in this response, the errors array contains information about the validation errors that occur during the create user mutation. And that's why it's giving you the path over there which says create user. Next, look at optimistic UI. Now, optimistic UI is a technique used to improve the perceived performance and responsiveness of applications by updating the UI optimistically before receiving a response from the server. This is often used in conjunction with the mutations to provide immediate feedback to the user while the mutation is still being processed. For example, after initiating a mutation operation to create a new user, the client might update the UI immediately to reflect the pending state of the new user, even before receiving confirmation from the server that the user has been successfully created. Now, by understanding all these concepts and techniques, clients can effectively use mutations to modify data on the server and handle errors and feedback in the GraphQL APIs. I hope this give you a good understanding of GraphQL mutations. If you have any questions, leave them in the comments, and we'll jump into GraphQL subscriptions next. GraphQL subscriptions. Now let's go over some of the subscription basics. Now, GraphQL subscriptions enable real-time communication between clients and servers by allowing clients to subscribe to events or data changes on the server. Unlike queries and mutations, which are request response based, subscriptions establish a persistent connection between the client and the server, enabling the server to push updates to the clients as soon as they occur. How does the subscription structure look like? A GraphQL subscription follows a similar structure to queries and mutations, but is used for subscribing to events rather than fetching or modifying data. Subscriptions define the events or data sources that clients want to subscribe to and specify the fields to be included in the subscription response. For example, a simple GraphQL subscription might look something like this, where I have a subscription for new post, ID, title, and body. So in this subscription, the client is subscribing to the new post event, which represents the creation of a new post. The subscription specifies the fields ID, title, and body to be included in the response whenever a new post is created. So if I want to subscribe to new posts being created on a particular website or for that backend, every time a new post is created, I'll get that new post along with these parameters ID, title, and body. Let's look at real-time data with GraphQL. Now, GraphQL subscriptions enables real-time data updates in applications by providing a mechanism for server to client communication over persistent connections. This allows applications to display live updates, notifications, or chat messages without the need for polling or manual refreshing. For example, in a chat application, clients can subscribe to a new message event to receive real-time updates whenever a new message is sent by another user in the chat room, which brings us to WebSocket protocol. Now, under the hood, GraphQL subscriptions typically use the WebSocket protocol to establish and maintain persistent connections between clients and servers. WebSocket connections provide full duplex communication channels that allow both the client and server to send data asynchronously in real time. By using WebSockets, GraphQL subscriptions can efficiently transmit data updates from the server to multiple clients simultaneously, enabling scalable real-time communications in applications with large number of users. Now let's look at how implementing subscriptions in GraphQL Server works. To implement subscriptions in GraphQL Server, you need to use a server implementation that supports subscriptions, such as Apollo Server or GraphQL Yoga. Additionally, you need to define the subscription event and the resolver functions in the GraphQL schema and server code. For example, you might define a subscription event for new post and implement a resolver function to handle the subscription logic, such as listening for new post and publishing updates to subscribed clients. By understanding these concepts here and the different techniques that we use, developers can implement real-time communication features in GraphQL APIs, GraphQL APIs, and build interactive and engaging applications with live updates and notifications. Let's look at some of the advanced GraphQL concepts. We'll start with enumerations. Now, enumerations, also called as enums, in GraphQL allow you to define a set of possible values for a field. Enums are useful for fields that should only accept specific predefined values, such as status codes or categories. For example, you might define an enum for the status of a task using here an example here where enum task status, it has to do, in progress, and done. So at a particular time, a task can have one of these status, which is to do, in progress, or done. Interfaces. Now, interfaces in GraphQL allow you to define a common set of fields that multiple types can implement. Interfaces enable you to represent shared behavior or properties among different types. For example, you might define an interface for a vehicle like this, where I have an interface vehicle which has an ID, make, and a model. Now, if you create a type of car which implements the vehicle, it has an ID, make, model, and also a year. You can also create a type bike which implements vehicle, which has ID, make, model, and then type of the bike. So this kind of helps you, the interfaces help you to implement the same vehicle interface multiple times for cars and bikes. Let's look at unions. Unions in GraphQL allows you to represent a type that could be one of several possible types. Unions are useful when a field can return different types of objects, but you want to query common fields across all possible types. For example, you might define a union for search results. Union where search results equal to book or movie author. Now, if it's type book, then it's title string, author is string. If it's movie, you give title and director. And if it's author, you give name or books. Let's look at fragments and composition. Fragments in GraphQL allows you to define reusable sets of fields that can be included in multiple queries. We've already seen fragments a little earlier, but fragments improve query maintainability and readability by reducing duplication of field selections. For example, you might define a fragment for user information in this particular format where I'm saying fragment user info on a particular user as ID, username, and email. Let's look at pagination. Now, pagination in GraphQL allows you to implement efficient pagination of large result sets. Pagination techniques include cursor-based pagination, offset-based pagination, and keyset pagination. For example, you might define a connection type for paginated results, something like this. Here we have a type query where we have users first, which of type integer, after string user connection. Now you have type of user connection which has edges and page info. We have type of user edge, which is cursor and node. And you have type of page info, which has next page and end cursor. Let's look at authorization and authentication next. Now, authorization and authentication in GraphQL involves implementing mechanisms to control access to certain fields or operations based on the identity and permissions of the requesting user. This often involves integration with authentication providers and implementing custom logic for authorization checks. Now, in this particular series, in this particular section, what we have done is we've learned advanced concepts developers which can use to design more flexible and powerful GraphQL schemas and APIs to meet complex requirements and use cases. If you have any questions on these, please let me know in the comments below. Thank you. Let's go over some of the GraphQL best practices. Now, for schema design best practices, some of the things that you follow is first is consistent naming. Maintain consistent naming conventions throughout your schema to improve readability and maintainability. Next is the clear documentation. Provide clear and comprehensive documentation for your schema, including descriptions for types, fields, and enums. Also, avoid overfetching. Design your schema to minimize overfetching by returning only the data that clients actually need. So it's why you use this. If you want to do overfetching, use the rest, right? So that's why GraphQL is best for this techniques. Next, about performance optimizing techniques. First one is batching requests. Use batching techniques to combine multiple requests into a single request to reduce round trip latency and overhead. Next is a data loader pattern, where you implement the data loader pattern to batch and cache data fetching operation, reducing database load and improving performance. Next best practice is caching. Use caching strategies to cache frequently accessed data and reduce the number of database queries. What are some of the error handling strategies? So first one is the consistent error format. Define a consistent error format for your GraphQL API responses to make error handling easier for clients. Second is the use GraphQL errors. Utilize GraphQL error types for structured error handling within your resolvers, allowing clients to distinguish between different types of errors. What are the best practices for security considerations? First one is input validation. Implement input validation to ensure that input data sent by clients meet the expected criteria and prevent common security vulnerabilities such as injection attacks. Second, authorization. Now, implement authorization checks to control access to certain fields or operations based on the identity and permission of the requesting user. Third one, rate limiting. Use rate limiting to protect against abuse and prevent denial of service attacks by limiting the number of requests a client can make within a certain period of time. Next, best practices for testing GraphQL APIs. First is unit testing. Write your unit test for individual resolver functions to ensure that they behave as expected and handle edge cases correctly. Second is integration testing. Perform integration tests to verify that your GraphQL API behaves correctly when interacting with the underlying data sources and dependencies. And the last one, schema validation. Validate your GraphQL schema against a schema registry or schema linting tool to ensure consistency and correctness. By following all these best practices for different things, you can design, develop, and maintain high quality GraphQL APIs that are efficient, secure, and scalable, providing a positive experience for both API consumers and developers. Next, let's look at GraphQL in production. Now, what are the deployment considerations? The first consideration is server environment. Choose an appropriate server environment for deploying your GraphQL server, such as cloud platforms, which include use AWS, maybe Azure, or Google Cloud. Make sure your containers are either Docker, or if you want to go serverless architecture, use AWS Lambda. Scaling strategies. Plan for scaling your GraphQL server to handle increased traffic and load by utilizing scaling strategies such as horizontal scaling, where you add more server instances, or vertical scaling, where you upgrade the server resources. Next is monitoring and logging. Once your server is once your application is up and running, you would want to have monitoring and logging. For that, first one is metrics collection. Implement metrics collection to monitor the performance and health of your GraphQL server, including metrics such as request latency, error rates, and server uptime. Also, second, logging. Set up your logging to record important events and errors occurring in your GraphQL server, enabling easier debugging and troubleshooting. What are the caching strategies? So, first strategy is data caching, where you use caching strategies to cache frequently accessed data and reduce the load on your database, improving response times and scalability. Next is response caching, where you implement response caching at the API gateway or CDN level to cache GraphQL query responses and reduce latency for subsequent requests. What are the strategies for scaling GraphQL servers? As I mentioned, there's two of them. One is horizontal scaling and vertical scaling. With horizontal scaling, you scale your GraphQL server horizontally by adding more server instances behind a load balancer to distribute incoming requests across multiple servers. For while doing vertical scaling, scale your GraphQL servers vertically by upgrading the server resources. Example, you want to upgrade your CPU, maybe memory, to handle these increased load on a single server instance. So depending on what the situation is, you can scale horizontally or vertically. And these days, a lot of different server environments give you these options. Next is versioning GraphQL APIs. First is semantic versioning. Follow semantic versioning principles to manage changes to your GraphQL API, including major, minor, and patch version increments to communicate the impact of changes to your API consumers. So if you want to say API version 1, that's not a right way of doing it. You can always say 1.0.0, 1.0.1, and then keep on incrementing where the first digit is the major, second is minor, and the last one is the patch version. Next is backward compatibility. Strive to maintain backward compatibility with introducing changes to your GraphQL schema to minimize disruptions for existing clients. So this is one of the benefits of using GraphQL. Next is deployment automation. You can use CI/CD, which is continuous integration, continuous deployment, where you implement CI/CD pipelines to automate the deployment process for your GraphQL server, including automated testings, buildings, and deploying new versions of your API. So this can all be automated once you understand what basic structure that you want to implement. Next is rollback and disaster recovery. Sometimes accidents happen, and for that, if you want to implement this, first is the rollback procedures, where you establish a rollback back procedure to quickly revert to a previous version of your GraphQL API in case of deployment failures or issues with a new release. Sometimes you release something and it has some binary issues or some problems, and if you want to roll back, make sure that you have your rollbacks in place. Sometimes even after you release, there are some more bugs than what it was before, so you'd want to have a rollback procedure. Next is disaster recovery. Implement disaster recovery measures such as backups and failover mechanisms to ensure the availability and integrity of your GraphQL API in the event of unexpected failures or disasters. By addressing these various considerations and implementing best practices for deploying and managing GraphQL servers in production environment, you can ensure the reliability, scalability, and performance of your GraphQL APIs to meet the needs of your users and applications. If you have any questions on this particular topic, do let me know in my comments. And next, we're going to look at integrating GraphQL with front-end techniques. In this particular section, we'll start with integrating GraphQL with front-end technologies. The first one is, let's talk about React and Apollo client. For Apollo client, you can use an Apollo client, a fully featured GraphQL client to integrate GraphQL APIs with React applications seamlessly. For queries and mutations, you can utilize Apollo client's query and mutation components to send GraphQL queries and mutations from React components. You can do cache management. Now you can benefit from the Apollo client's built-in caching capabilities to manage local and remote data efficiently and provide a smooth user experience. You can also have real-time updates where you can leverage Apollo client's support for GraphQL subscriptions to receive real-time updates from the server and update the UI accordingly. How about using Vue.js and Vue Apollo? With Vue Apollo, integrate GraphQL's APIs with Vue.js application using Vue Apollo, a GraphQL client for Vue.js. You can also have components integration using Vue Apollo's integration with Vue components to execute GraphQL queries and mutations from Vue.js components. Reactivity. Now you can take advantage of Vue Apollo's reactivity system to automatically update the UI in response to changes in the underlying data provided by GraphQL queries. You can also use pagination and error handling, where you implement pagination error handling strategies with Vue Apollo to manage large data sets and handle errors gracefully. How about Angular and Apollo Angular? Apollo Angular, you can integrate GraphQL APIs with Angular applications using Apollo Angular, a GraphQL client for Angular. You can use GraphQL modules, where you can organize your GraphQL code into modules using Apollo Angular's support for GraphQL modules to improve code organization and maintainability. You can do type safety, where you can benefit from Apollo Angular's type safety GraphQL queries and mutations using TypeScript to ensure type safety and improve developer productivity. You can also create an optimistic UI. You can implement the optimistic UI updates with Apollo Angular to provide immediate feedback to users and improve perceived performance. How about native mobile apps with GraphQL? You can use React Native and Apollo Client. You can use React Native along with Apollo Client to build native mobile apps that consume GraphQL APIs and share code between web and mobile platforms. Next is Apollo Client for iOS Android. You can integrate GraphQL's APIs with native iOS and Android apps using Apollo Client support for iOS and Android platforms. How about offline support? Now you can implement offline support with GraphQL using tools like Apollo Client's offline persistence to allow users to interact with the app even when offline and sync data with the server later. Authentication and authorization. You can implement authentication and authorization mechanisms with GraphQL APIs in mobile apps to secure access to sensitive data and resources. By integrating these GraphQL APIs with front-end technologies such as React, Vue.js, Angular, and native mobile frameworks, developers can build modern, interactive, and responsive applications that leverage the power and flexibility of GraphQL for data fetching and management. If you have any questions on these, just let me know in the comments and I'll get back to you. Next, let's look at real world example and case studies. Now, if you want to build a blogging platform with GraphQL, first thing that you need to do is schema design. Design a GraphQL schema to represent blog posts, authors, comments, and other relevant entities. Next, you'll have to look at CRUD operations, which is implement your CRUD operations, which is create, read, update, and delete using GraphQL mutations for managing blog posts, comments, and user profiles. You can implement pagination by using techniques like efficiently handling large number of blog posts and comments. Authentication and authorization. Integrate authentication and authorization mechanisms to secure access to certain features and data within the blogging platform. Next is the real-time updates. Implement real-time updates using GraphQL subscription to notify users of new blog posts, comments, or updates to existing content. How about integrating GraphQL into e-commerce application? For this, you'll need to have a product catalog where you design a GraphQL schema to represent products, categories, and other e-commerce entities. You can implement search and filtering, where you can use GraphQL queries to allow users to find products based on various criteria. Shopping cart management. Use GraphQL mutation to manage shopping cart items, update quantities, and process checkout transactions. Next is user profile and orders. Implement user profiles and order history functionality using GraphQL queries and mutations to provide personalized shopping experience. And last is the performance optimization. You can optimize queries query performance using the techniques such as data batching, caching, and server-side optimization to improve the responsiveness of the e-commerce application. Next application we can look at is GraphQL in social networking apps. Now you have to think of user profile connections where you design a GraphQL schema to represent user profiles, friendships, followers, and other social networking features. You'll need a news feed where you implement a news feed using GraphQL queries to aggregate and display relevant content from a user's network. Notifications. Use GraphQL subscriptions to notify users of new messages, friend requests, or other relevant activities in real time. How about content sharing? Enable users to share content such as post, photos, and videos using GraphQL mutations to create and publish new content. Privacy settings. Implement privacy settings using GraphQL queries and mutations to allow users to control the visibility of their content and interactions with others. What are some of the lessons learned from large scale GraphQL implementation? First one is performance consideration. Discuss performance consideration and best practices for scaling GraphQL APIs to handle large number of concurrent users and requests. Talk about schema complexity. Address challenges related to schema complexity, including managing nested queries, optimizing resolver performance, and minimizing overfetching. Next, tooling and monitoring. Explore tooling and monitoring solutions for GraphQL APIs, including schema validation, query performance analysis, and error tracking. About versioning and evolution. Discuss strategies for versioning and evolving GraphQL APIs over time while maintaining backward compatibility and minimizing disruptions for the client. Talk about community insights. Now, share insights and lessons learned from GraphQL community, including common pitfalls, best practices, and emerging trends in GraphQL development. By examining all these real world examples and case studies of GraphQL implementation in various domains such as blogging platforms, e commerce application, and social networking apps, developers can gain practical insights and learn from best practices and lessons learned from large scale GraphQL deployments. If you have any questions on this, let me know in the comments and I'll get back to you. Welcome to Beyond Basics, or more like advanced topics. Now, in this particular section, we're going to talk about custom scalars, middleware in GraphQL, GraphQL federation, and schema stitching. Also, we'll talk about GraphQL and microservices architecture. So let's start with custom scalars. Now, custom scalars allow you to define custom data type with specific serialization and parsing behavior in GraphQL schemas. The use cases are use custom scalars to represent specialized data types such as dates, email, addresses, or custom identifiers. How do we implement this? You can implement custom scalar types by defining serialization and parsing logic for input and output value in GraphQL resolvers. To talk about middleware in GraphQL. Middleware in GraphQL refers to the functions or logic that execute before or after resolver functions to perform additional processing of or manipulating of data. Use cases for this are use middleware to implement features such as logging, authentication, authorization, caching, or data validation in GraphQL servers. For implementation, you implement middleware functions using middleware frameworks or libraries such as Apollo Server plugins or custom middleware logic in GraphQL resolvers. Let's look at GraphQL Federation. GraphQL Federation is an architectural pattern for building distributed GraphQL APIs by composing multiple GraphQL services into a unified graph. Use cases include use GraphQL Federation to divide large GraphQL schemas into smaller independent services that can be developed, deployed, and scaled separately. Implementation for this is implement GraphQL Federation using tools and libraries such as Apollo Federation or GraphQL Mesh to define and compose federated schemas from individual GraphQL services. How about schema stitching? Now, schema stitching is a technique for combining multiple GraphQL schemas into a single unified schema that exposes a consolidated API to the clients. Now, use case in this case is use the schema stitching to integrate existing GraphQL services or legacy APIs into a unified GraphQL gateway or to compose federated schemas in GraphQL Federation. Implementation of this implement schema stitching using schema stitching libraries or frameworks such as Apollo servers, schema stitching utilities, or GraphQL tools. And last one is GraphQL and microservice architecture. GraphQL well suited for microservice architecture where individual services are responsible for specific domain areas and communicate via APIs. Use cases for this is use GraphQL to define and expose APIs for microservices, allowing clients to query and mutate data across multiple services using a single GraphQL endpoint. Now, implementation for this implement microservices architecture with GraphQL by defining service specific schemas and resolvers and exposing them through a GraphQL gateway or federation layer. By exploring all these advanced topics in GraphQL, developers can extend their understanding beyond the basics and leverage advanced techniques and patterns to build more flexible, scalable, and maintainable GraphQL APIs and architectures. If you have any questions on this advanced topics, let me know in the comments and I'll get back to you.